Hello learners. Let me ask you something. Have you ever tried to find the maximum area for a garden or wondered how certain parabolic shapes are calculated in architecture? Well, behind these seemingly simple situations lies the powerful tool of mathematics, the quadratic equation. A quadratic equation is any equation that can be written in the standard form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and is not equal to 0. Why is it called quadratic? Because the word comes from quadratus, meaning square. The variable is raised to the power 2, which is what makes the equation quadratic. For example, if you take the equation 2x squared plus x minus 300 equals 0, this is a perfect quadratic equation. We'll see shortly how this can arise from real-world scenarios. Let's connect this to a practical situation. Imagine a prayer hall in a school. The area of the hall is given as 300 square meters. Let's say the length of the hall is 1 meter more than twice its breadth. So, we assign the breadth as x meters. That means the length becomes 2x plus 1 meters. Now area is length into breadth, right? So we multiply x with 2x plus 1. That gives us area equals to x squared plus x. We are also told that this area is 300 square meters. So we equate 2x squared plus x equals 300. Let's rearrange that. 2x squared plus x minus 300 equals 0. This is a real-life situation producing a quadratic equation. Visualize it as a rectangle where one dimension is expressed in terms of the other. This is how math naturally arises from geometry. Now that we've seen a real-world example, let's zoom out in time. Did you know that people were solving quadratic equations over 4,000 years ago? The Babylonians were among the first to tackle problems where they had to find two numbers with a given sum and product. Sounds familiar? Yes, that's exactly what quadratic equations represent. These problems can be expressed in the form x squared minus px plus q equals 0. In ancient Greece, mathematician Euclid found geometric methods to solve such equations using lengths and areas. It's fascinating how abstract equations we use today were once drawn out using lines and squares in sand or clay tablets. Let's now celebrate India's pioneering contribution. The great mathematician Brahmagupta, around 600 CE, gave rules to solve quadratic equations of the form ax squared plus bx equals c. He worked with both positive and negative roots and even imaginary numbers. Later, Sridharacharya, in the 11th century, gave what we now call the quadratic formula, the one that solves ax squared plus bx plus c equals 0. This formula, as refined later, is x equals negative b plus or minus square root of b squared minus 4ac whole divided by 2a. This was centuries before Europe developed similar techniques, a proud heritage of mathematical brilliance. Let's now consolidate our understanding with the general form of a quadratic equation. The standard form is ax squared plus bx plus c equals 0, whereas not equal to 0. Here, a is the coefficient of x squared, b is the coefficient of x, and c is the constant term. If a is 0, then the equation becomes linear and no longer quadratic. Understanding this structure helps us choose the right solving method, factorization, completing the square, or the quadratic formula. Let's take an example, 3x squared minus 5x plus 2 equals 0. This matches the form where a equals 3, b equals negative 5, and c equals 2. So why should you care about quadratic equations? Let me show you how they pop up everywhere. In physics, when you calculate the trajectory of a ball, the path is a parabola described by a quadratic equation. In economics, profit functions and revenue models often lead to quadratic equations. Even in construction, finding dimensions with a fixed area involves forming quadratic equations, just like our earlier prayer hall example. In short, whenever you're dealing with optimization, curves, or area relationships, quadratics are quietly at work in the background. Let's quickly revise what we've learned today. Quadratic equations are second-degree polynomials written as a x squared plus bx plus c equals 0. They arise naturally in real-life contexts like calculating area, motion, and design. Babylonian, Greek, and Indian mathematicians explored these equations thousands of years ago. Indian scholars like Brahmagupta and Sridharacharya formalized methods that are still used today. And finally, understanding the structure of a quadratic equation prepares us to learn the different ways to solve them. I hope now you have a strong foundational feel for what quadratic equations are and why they matter. In the next video, we will discuss quadratic equations in greater depth, including how to solve them using methods like factorization, completing the square, and a quadratic formula. So stay tuned and get ready to dive deeper into this powerful mathematical tool.